Problem number 8. We have a vector field f given here. We have a half sphere S with this equation here. Here's a picture of it. It's the half sphere where z is non-negative. Choose normal vector n to the surface, so it's composed positive, so that will be outward oriented. Okay, that's unsurprising. Use Stokes' theorem to find the flux of the curl of f over the surface S. So we should know Stokes is going to say here the double integral over S of the curl of f dot ds is going to equal, this is going to equal the integral around the boundary of S of f dot dr. And so where is the boundary? That's the boundary right there, oriented as usual counterclockwise. So let's parameterize the boundary. To parameterize the boundary here, it's going to be a circle. It's going to be a circle of radius 3. So this is a sphere of radius 3. And so the boundary here will be a circle of radius 3. 3 cosine t, 3 sine t. Z will always be 0. But our answer isn't quite this. Why not? Because our circle is centered at the point 0, 3, 0 is the center there. And so we just left it like this. This would be a circle, radius 3 oriented counterclockwise, centered at the origin in the xy plane. But to account for the fact the y coordinate is 3, excuse me, we need to tack on 3 right there, a plus 3. Okay, so here is our r of t. R prime of t will be negative 3 sine t and 3 cosine t and 0. We would also need f of r of t. So negative y becomes negative 3 sine t minus 3. X is 3 cosine t plus z is 0. E to the 0 squared. That's not really going to matter because our next thing is f of r of t dot product r prime of t. So this, excuse me, this dot product with this, 9 sine squared t plus 9 sine t plus 9 cosine squared t. Oh, look, I see a 9 right here, 9 plus 9 sine t. So then to finish off our integral here, this integral is equal to integral from 0 to 2 pi. That's the bounds in our parameterization here of f of r of t dot product r prime of t, 9 plus 9 sine t dt. And the integral of the 9 sine t term will be 0. So then we're just left with 9 times 2 pi is 18 pi.